Lesson: Phases of AI Model Development. The development of AI models is a multifaceted process that requires a structured approach to overcome inherent complexities and achieve optimal performance. The phases of AI model development are critical and interdependent, each playing a vital role in the lifecycle of AI systems. Understanding these phases provides actionable insights into the practical tools and frameworks that professionals can employ to address real-world challenges and enhance their proficiency in AI model development. The first phase in AI model development is problem identification and scoping. This phase involves understanding the specific problem the AI system is intended to solve and the requirements it must meet. Clearly defining the problem's scope helps avoid the common pitfall of project creep, where unplanned features are added, leading to increased complexity and resource allocation. For instance, in developing an AI model for predictive maintenance in manufacturing, it is crucial to identify the types of equipment, failure modes, and data sources required. Tools such as the business model canvas can be instrumental in mapping out the business context and ensuring that all stakeholders have a shared understanding of the project's objectives. Once the problem is defined, the next phase is data collection and preparation. Data is the backbone of any AI model, and its quality directly impacts the model's performance. This phase involves gathering relevant data, which may be structured or unstructured, and preparing it for analysis. Data preparation includes cleaning, transformation, and normalization to ensure consistency and accuracy. Practical tools like Python's Pandas library and data preprocessing frameworks, such as TensorFlow's Transform, are invaluable for handling large datasets efficiently. Real-world case studies, such as Netflix's recommendation system, highlight the importance of high-quality data. Netflix leverages vast amounts of user data to personalize content recommendations, significantly enhancing user engagement. Following data preparation, the next phase is feature engineering. This involves selecting and transforming data attributes into features that effectively represent the underlying patterns necessary for the model to learn. Feature engineering is a creative process that requires domain expertise and experimentation. Tools such as scikit-learn's feature selection module can be used to automate part of this process, helping to identify the most relevant features. A successful example of feature engineering is seen in the financial industry, where companies develop credit scoring models. By transforming raw financial data into features like credit utilization ratios and payment histories, these models can reliably predict creditworthiness. After engineering features, the focus shifts to model selection and training. This phase involves choosing the appropriate machine learning algorithm and training it on the prepared dataset. The choice of algorithm depends on several factors, including the type of data, the complexity of the problem, and the desired model outcomes. Algorithms such as decision trees, support vector machines, and neural networks each have unique strengths and weaknesses. Tools like TensorFlow and PyTorch provide robust frameworks for building and training models, offering extensive libraries and community support. For example, TensorFlow's Keras API simplifies the process of building deep learning models, making it accessible for both beginners and experts. Model evaluation and validation are crucial to ensure that the AI system performs well on unseen data. This phase involves testing the model using a separate validation dataset to assess its accuracy, precision, recall, and other performance metrics. Cross-validation techniques, such as k-fold cross-validation, help in obtaining a more reliable estimate of the model's performance by reducing variance caused by the random sampling of the training and validation sets. A practical example is the use of A/B testing in digital marketing, where AI models are evaluated based on their ability to predict customer behavior and optimize marketing strategies. Once the model is validated, the deployment phase follows. This involves integrating the model into a production environment where it can be used to make real-time decisions. Deployment requires careful consideration of scalability, latency, and integration with existing systems. Cloud platforms like AWS, Azure, and Google Cloud offer services such as AWS SageMaker, Azure Machine Learning, and Google AI Platform, which streamline the deployment process and provide tools for monitoring and maintaining models in production. An example of successful deployment is in the healthcare industry, where AI models are used to assist in diagnostic imaging, providing doctors with real-time insights and improving patient outcomes. The final phase of AI model development is monitoring and maintenance. Continuous monitoring is essential to ensure that the model remains accurate and reliable over time. This involves tracking performance metrics and retraining the model as necessary to account for changes in data distribution or the emergence of new patterns. Tools such as MLflow and ModelDB provide platforms for tracking model performance and managing the lifecycle of machine learning models, facilitating collaboration and reproducibility. In practice, companies like Uber use these tools to maintain their dynamic pricing algorithms, ensuring they remain responsive to real-time market conditions and customer demand. In conclusion, the phases of AI model development constitute a comprehensive framework for building effective AI systems. Each phase, from problem identification and data preparation to model training, evaluation, deployment, and maintenance, is integral to the success of the AI project. By leveraging practical tools and frameworks, professionals can navigate the complexities of AI development and deliver solutions that meet the needs of their organizations. Through real-world examples and case studies, it is evident that a systematic approach to AI model development not only enhances proficiency, but also drives innovation and competitive advantage.